All right, so now let's do an example where we run through this entire procedure for a hypothesis test, this Phantom's procedure. Benford's Law and fraud. When the accounting firm AJL and Associates audits a company's financial records for fraud, they often use a test based on Benford's Law. I think we had some examples with Benford's Law before, but you don't need to know what that is. Benford's Law states that the distribution of the first digits in many real-life sources of data is not uniform. In fact, when there is no fraud, about 30% of the numbers in financial records begin with the digit 1. If the proportion of first digits that are 1 is significantly different from 30% in a random sample of records, the auditing company will audit the company more thoroughly. Suppose that a random sample of 300 expenses from a company's financial records results in 68 expenses that begin with the digit 1. Should the audit company audit this other company? Run a significance test at an alpha level of 0.05. All right, so first let's just see what kind of sample proportion they got. They got 68 out of 300 records. Let's see what that is. Excuse me. 68 out of 300. So that is 22.7%. So we were supposed to get 30% of the records start with 1 and only 22.7% start with 1. So you might ask, why is there a difference? One explanation would be that, when we take a sample of 300, there's going to be sampling variability. So maybe this was just a random chance occurrence. Maybe the true proportion is 301, but because of sampling variability, I got the 227. That's one explanation. Or maybe I got this value because the true proportion of records at this company that start with 1 is less than 301% or different than 301%. Sorry, 301.301. So the question is this difference significant or not? Well, let's run a significance test. P, parameter of interest. Parameter of interest is a proportion, a population proportion. So this is the true population proportion of this company's records. We'll just say of records, of financial records. Oh, no, I spelled financial, sorry. Financial records at this company that start with 1. Okay. Set up our hypotheses. The null is going to be P equals 0.301. Remember, the null is always equals. And then the alternate. The alternate is that the true proportion is, all right, greater than, less than, or not equal to. Now, if you look at the sample is less than. So you might be tempted to just say less than because, look, it's less than. But you're supposed to pick that alternate hypothesis before you do your study. If you read the question carefully, it says, if the proportion of first digits is significantly different from 301, then they're going to audit the company more thoroughly. So it could have been higher than 30% or lower. So not equal to is going to be our alternate. Okay? Assumptions and conditions. 1. They took a random sample. We need a random sample so that we know that our p-hats are going to be unbiased estimators for the true proportion. 2, 10% condition. N equals 300 is likely less than 10% of all records. at this company. So I'm going to kind of make that assumption that that is true. And then 3 is large counts. I need to check N P naught, which is 300 times 0.301. I don't know what that is, but that's going to be 100-ish or 90 something. Certainly bigger than 10. So we're good. And then NQ naught. And we are definitely good on this one. That's 1 minus 0.301. Complement of that. So we got a big sample. Therefore, the sampling distribution of p hat is approximately normal. Again, I kind of say on the AP test, I don't think they require this, but I like it. It's a normal check. If you just put large counts in this, I don't see any normal in there, so I don't like it. On my test, you have to do this, and you have to make sure you say p hat here, so please be careful. All right, so we're good. Our sampling distribution is going to be normal. N, name the test. This is a 1 sample. Z test for proportions. And technically on this step, you got to give the formula, but we could also give the formula for the T step. Calculate the test statistic. It's going to be a Z test statistic. For symbols, it's going to be p hat minus p naught over the standard deviation of the sampling distribution of sample proportions under the assumption that the null is true, that. What's it going to be? It's going to be 68 out of 300 minus 0.301 divided by the square root of 0.301, 1 minus 0.301, all over 300. So that's the test statistic with numbers plugged in. So let's put this in the calculator. I'll pause the video to save a little time. So I plug this into the calculator, just like you see it. Hit enter. So my test statistic is negative 2.81. So Z equals negative 2.81. Okay. Now we need to obtain the p-value. To obtain the p-value, we have a normal sampling distribution. This is the standard normal Z-curve. And my test statistic is going to be negative 2.81. It's going to be like right there. So let's look at our alternate. Our alternate is a two-tailed. So to do that, we're going to find the area to the left of our test statistic and to the right of positive 2.81. Basically, find one area and double it to get the p-value. So to find one area, I'm going to do a normal CDF. Menu, statistics, distributions, normal CDF from the lower bound to my last answer, because my last answer was that negative 2.8. Standard normal, keep that the same. And it gives me negative 0.0025. That's the area on one tail. Then we need to double it to get the area for two tails because it's a two-tail test. Your p-value for a two-tail test is always going to be twice the size of the p-value for a one-tail test. Well, usually 0.0050. So p-val equals 0.005. Now, I've always been a stickler about showing your work on this step. You know, with these normal curves on this, you do not need to show your work. In fact, you can just type all of this into your calculator to get this value and this value if you want. And let me show you how to do that as well. I would encourage you to do one or two by hand, but on a test, you know, there's just a lot of places to make mistakes. So we would just, you know, type in the calculator. So on the test, or excuse me, on the calculator menu, statistics, we want to do a stat test, and we want to do a 1 proportion z-test. These first four options are for means, and these are for proportions. So 1 proportion z-test, option 5. P naught, that's the null hypothesis, 0.301. How many successes? Well, 68 records started with 1. out of a sample size of 300. And here's where you select your alternate. I want a two-sided alternate. Hit OK. And it gives you all the good stuff. It gives you the test statistic, the p-value. It actually calculates the p-hat for you and reminds you of what your sample size is. We're just going to copy down these two things on our paper for this test. Okay? Please use that on the test. If I want to test to see if you know the mechanics, I'll test that on other questions. Here, just use the calculator, okay? All right, now the important stuff. Make our conclusions. Here's our statistical decision. You need to explicitly compare your p-value. That is going to be less than our alpha value of 0.05. And if our p-value is small, that means we have evidence against the null, so let's reject the null. There's our statistical conclusion, and now we write our non-statistical conclusion. We do have convincing evidence that so let's go back up to the top here and copy the true proportion of financial records that start, copy that down word for word, that the true population proportion of financial records that start with 1 at this company is, so now what are we going to put down? Look at your alternate. You always word it in terms of the alternate. Always. Not equal to 0.301. There's our conclusion. So basically we have convincing evidence that it's not 30%, so we should do a more thorough audit, more in-depth audit. This is kind of optional, but I mean that's the conclusion you kind of want to make. But you can make both of these, or you could just do this one and not do this one. But don't think you can just do this one here, because this one does not replace this one here. They want to see you make a conclusion in terms of the parameter of interest and the alternate hypothesis, okay? Now, if this p-value would have been greater than, the only thing I would have changed is I would have said we do not. Okay? You still word it in terms of the alternate, it's just we don't have enough evidence. Okay? If you don't word it like that, then you might accept the null and say we have evidence that the true proportion is 30%, and we don't know that. We just don't have enough evidence to say it's not 30%. Use your calculator to quickly construct a 95% confidence interval. Is 30.1 in this interval? So let's just do the mechanics on this one. Statistics, confidence intervals, 1 prop z interval, 68 successes out of 300, 95%, 0.179274, 0.179.274. Notice the 30% is not in this interval. So the idea here is that a confidence interval kind of tells you the same thing as a significance test. Since 30% is not in the interval, then I have significant evidence, convincing evidence, enough evidence to say that the true proportion is not 30%. In fact, I think it's somewhere between these two. So we can kind of make the same conclusion with a confidence interval, but please, if I ask you to do a confidence interval, please do a confidence interval. Don't try to do a if I ask you to do a significance test, please do a significance test. Don't try to do a confidence interval instead, okay? Right tool for the right job. All right, so we need to talk about errors next video.